Hey, what's up, Lighting World? You got the Lighting Amigos back. We're continuing our seven deadly sins, kind of, I don't know, what do you call it? Collage of thoughts here. We're jumping back on with sin number 5. To the right of me, I got Captain Mateo, Captain Feo Mateo, what
Hey,
they
hey,
call
hey. That's what they call
and
me.
Nate the Illuminator here at the bottom. So welcome, guys. Good to see you guys again. It's another day. Nate, I can tell you're ready for St. Patty's Day. As an Irish feller with what is your last name? Mullen. That sounds
Yeah,
Irish. Mine,
yeah. I don't even know. When is St. Patrick's Day? That's this weekend? How bad is that? I don't even know.
it's Monday.
He's wearing
It's
all
Monday.
green for those that are just listening. He's got a green
He's
on his
Right.
wearing
hat. He's got a green shirt. I've got a green.
Yeah,
Hey, we're all got green on. What's going on right
yeah,
now?
no,
yeah,
yeah,
yeah.
it
There's
wasn't
nothing wrong.
even trying. But
I mean, you got to
yeah,
admit the fighting Irish, that little, everybody has their tattoo. That fighting Irish guy. That's one of the most badass, tattoos or logos out there.
funny enough, I actually have a four-leaf clover tattoo, but you guys didn't even know that.
I did not know that.
I did not know that either.
Yeah, I
Interesting.
mean, I'm not all sleeved up and cool like Matt, but I got a shoulder one, proud Irish background. Which you know what, we took a. I'm getting off subject. But we took one of those ancestry tests. Turns out I'm more Scottish than Irish. Super disappointing.
Yes, it is crazy what those DNA tests show.
St. Patrick Duffy.
And
So
that would be super interesting to find out what our true heritage is. We just got the stories from great grandmother to great grandmother, right? And all this shit. Like my great great grandmother told me we came over on the Mayflower because her last name's Mullen. I'm sure that's the biggest lie in the world, right? you know, but I think she was just trying to make me feel better because we were just white trash at the time. So what
get
are we
back on
doing today, Shane?
So, sin number 5. So, we've got required voltage and wire management. So, super important, right? Because voltage drop is definitely a killer of your design, and you need to know what to do to avoid it. Wire management, right? What gauge do you use? How are you going to do it? You do the hub method? Do you daisy chain? How many lights can you put on one home run? How many home runs do you need? So, all kind of questions that kind of get new folks like a deer in the headlight and just kind of just kind of pause and not really know what to do. So let's talk through that a little bit, common mistakes, and how someone that is new listening can overcome those.
Well,
Nate, I'm gonna
can I just?
Yeah,
What is
go ahead,
voltage
Matt.
drop? I mean, you're talking about voltage drop. I don't think I've recently heard that been discussed in the industry.
So
What is voltage drop though?
VD, what is VD? That it's voltage drop. Um, there's several things that I would call VD: voltage drop, voltage distribution. But I think we should go just a tiny bit of history here, because obviously this is super important when it comes to. I mean, if you're doing a 10 light job, if your average job is 12 lights, nothing matters, right? You could probably just click off the podcast, go listen to Fleetwood Mac or something, because small jobs aren't necessarily important. But when you start getting into long runs, and a long run could be 100 feet, or you start getting into, 50, 100 larger size jobs, I mean, all of this is super, super, super important. And what's a shame in the industry, Matt, what you just said is you haven't even heard about it. That's because manufacturers today are doing our industry a disservice. And if I'm listening to this podcast and I want to be a lighting guy and I'm trying to make my profession at what I'm doing, I am fucking pissed off at all the manufacturers out there because they have an obligation to teach you the truth. They have an obligation to keep you informed, and they don't do that. My background is being an electrician. So we are always informed and did things correctly and kept up with the industry. Today, our industry, the manufacturers, wherever you buy SiteOne, Horizon, all of these companies, they don't know anything. And what they do is they tell you none of it matters. LEDs, just nothing matters. No voltage, use a multi-tap transformer, this and that, right? Use 12 wire everywhere. And it's such a disservice to our industry because that's not true, right? You can sit there and LED for one, right, requires several things. So this is part of voltage drop and it's part of what it requires. It's like if you bought a car like my Porsche or my Maserati, it specifically tells me use 91 octane. Well, I can't go put 87 in it because it'll ping, it won't run very well, probably blow the engine up. LEDs are the same. They require DC voltage. So, but everybody powers them up with AC. Now, what happens is a thing called volt amps. And that's super important because every single light bulb out there that you're installing, that you're buying from SiteOne or Horizon or whoever, um, there's a thing called volt amps, and that's going to increase the wattage by 50%, 60%, 70%. The reason that's important, voltage drop. So you're going to look at a chart, if you can even find one, right? That's going to tell you you can get 1 volt drop for maybe every 100 feet. Well, that's without VA. You add VA in it, it's going to be 2 volts per every 100 feet. So the magnitude of voltage drop has increased almost exponentially over halogen in the old days. So voltage drop is more prevalent today than it was technically with halogen. So it is super important. So I'm very
You know, I
concerned
mean,
with that.
I was gonna say, when you talked about the wiring sizes, when you go to supply houses, they have 10 gauge, 12 gauge, and 14 gauge. So like the common answer when someone says a light stem is they're just like, it's the answer. Oh, use 10 gauge. Oh, use 10 gauge. I have a long run. Use 10 gauge. There's no thought behind it because they know typically a 10 gauge is going to be enough. And so instead of teaching them, do they even need 10 gauge? Or they need 12 gauge? Why do they need that? It's just, yep, buy 10 gauge, run 10 gauge. It's just, I don't think I've ever used 10 gauge. I mean, not that you can't, there's not reasons for it, but
Well, I mean, I know guys that still use 10 gauge because they're so scared they don't want to do calculations. They're paying $1 a foot, right? So, it's if you do things properly, and I don't like to use the word engineering, if you will, but I call it like a power management system, right? To where it takes 3 things to properly engineer a job, right? It takes the power, which we'll call it a transformer, which you don't want to use anymore. You want to use a power driver. So it takes the heart of the system. You need a power driver. And then you need a wiring method, and that'll be maybe one of the acronyms of VD, voltage distribution. So you got to have the power supply. You got to have voltage distribution, which goes through your sizes of wire, whether it be 10, 12, 14, or 18. And then then it goes to the fixture, which obviously the fixture is really an LED. So power driver, wiring method, voltage distribution to the LED. It takes all 3 of those things in combination. And you need to know things like this. So for us, right, the proper wiring distribution starts off with 24 volts. So when you think about it, every single person out there in the industry knows that every irrigation system in the world runs off 24 volts. Everybody knows that. And why don't the irrigation? They're just working a tiny little solenoid. Nothing. You can't. They the solenoids pull such minimal amount of electricity. They don't even register on an amp probe. Can't even register the amount of electricity they pull because they pulled nothing. But the irrigation industry knew that voltage drops a problem, and if you go 12 volts, the solenoids aren't going to work. So they go 24 volts. So I would go 24 volts. So in 24 volts in simplicity, 12 versus 24, it's double good. Twice as many fixtures on the same cable. You can go twice as far. So getting back to, you would never need 10 now. You could really get by with 14, not even 12, if you went with 24 volts. So that's the best way to get distribution out there, is going with a 24 volt system. But your suppliers don't carry 24 volt because they don't want to have double the inventory. They don't even want to tell you about 24 volts. But
Nate, I got to interrupt you for a second. You're going off and you're at a higher level, right? You're talking electrical talk, and it's probably going over some folks' head. Just as if I was a kindergartner and you're trying to explain to me just electricity in general, let's just kind of start back. Electricity at the house is 110 to 120 volt, right? Everyone hears that 110, 120. That's coming out of the house. We use a power supply and it converts it to 12 volts, or you just said 24 volts because 24 volts is better. So question that I would have is, why does 110 volts not get voltage drop like in everyday electricity in houses and whatever, versus why do we in landscape lights have to worry about that?
pretty simple question, Shane, is if you just say, let's use 120, not 110, right? Because it's really more 120 than 110. and then you got 12 volts. So 120 in, 12 out. That's a 10-to-1 ratio. And that's a true linear ratio. So you have 10 times more power, right, on a 120-volt system than you do 12. Now, just for fun out there, don't get bored, but you need to know how many fixtures you can put on a wire, right? I think Matt said that at the very beginning. So it's a real simple formula. I call it ATV, amps times volt, amps times volt. Everybody knows what an ATV is. It's a little utility vehicle you drive around. So if you took 12.2, all right, 12.2 is good for, 20 amps. So if you take 20 amps, you take your amps times your voltage, so 12 times 20, right, is what is 12 times 20? 240, right?
Yeah.
And you can go 80%, so it's 192. So I'll call it 200. Say your average fixture was 4 watts. You can put maximum, you can put 40, 50 bulbs on that 12.2. That's how many lamps you can put on it. Now, if we did the same thing on 120 volts, right? You would take that 40 watts and 40 lamps on 12.2 on a 12-volt system, you would get 400 fixtures on a 120-volt system. 10 times more. You imagine if you use 120 volts, you get 400, right? On the same wire. So obviously, getting back to the 24 volts, if I can get 40, right, or 50 on 12 volts, I can get 80 to 100 on 24. I would be the biggest idiot in the world not to use a 24-volt system. An idiot, right? Why wouldn't I? So
But I
when
guess
you look at, go ahead.
so. I mean, to Shane's thing, is there voltage drop on those 120 lines from like my panel to my outlet? Like, do they not have to
Yes.
worry about it?
This is
In
just 120 to dropping down to a 105 just isn't a big deal. You
so
have
so typically in a normal house, absolutely not. You go into a bigger house, maybe it's 6,000 feet, 5,000 feet, right? Now, in two-story house, no, because obviously you've doubled you got half the footprint, you double in size, so you don't have, you're not going far. But if you took a ranch style home that was 6,000 square feet, long runs now, what electricians do is they do a distribution. They would put a sub panel halfway through the house with massive big cable going to the sub panel and then have runs from the sub panel, right? So again, this would be part of our power management system, our voltage distribution, which we do the same thing in low voltage. Start off with 12, go to 14, downsize to 18. Same thing we do in every commercial job in the world, every home in the world. You do some type of a structured system, bigger wire to smaller wire, so you can minimize voltage drop. But yeah, you get voltage drop. I mean, in my home, just for example, say from where I'm pulling my main feed from to my motorhome garage, I'm going to say it goes, I don't even know, 300 feet. Yeah, I had like 96 volts down there, and I had to put a buck boost transformer down there to go from 96 back up to 120 voltage drop. Okay,
Oh.
so happens everywhere. Nobody is not immune to VD.
So I use, because Nate told me to, 24 volts because it's better. I can double the amount of fixtures, double the distance run. So that math isn't really anything I normally have to do on a job. Even the 200 fixture and job we're installing right now, that's still not really a math problem that I need to do. So yeah, I don't know what the question is there, but I guess just I don't know, 24 volts is better, right? So if you're new, if it's 24 volts, you use less wire, which is going to save you money, and you just really don't have to worry about the math as much, because if you drop 7 volts on 24 volts, I mean you're still good. Is that a fair statement, Nate? Versus 7-volt drop on a 12-volt system, you've got
So
issues.
let's go back to what you just said, that you do a 24-volt system. There is another variation which you do, Shane. It's called the varivolt system. So we have a special proprietary light bulb that will operate without any lumen depreciation, lamp life depreciation, efficiency, anything. It'll get the same amount of lumen, same amount of energy being pulled from basically 12 volts to 42 volts, if you will. All right. So that allows us, and we feed it with 26.8, not 42. So we feed it with 26.8. So we've got a 14 volt range that we can drop voltage on. So in that scenario, we can go, it's almost like a 120 volt system. We could go hundreds and hundreds and hundreds of feet because we don't care if we got 16 volts or 15 volts or 14. That's a different variation called varivolt. So, but in simple terms, you can go in a straight 24 volt system, you can go twice as far or put twice as many fixtures on it.
Well, let me ask a question about that because I had a gentleman who I was talking to about the Varivolt system. Obviously, comes out of 26.8. A lot of guys just call it 24 out of simplicity. And this other manufacturer told him that it was illegal for us to be using 26.8 volts or even 24 volts. I know that's nonsense, but they scared him. They showed him some sort of code in the code book. So are you having us just install illegal things? Are we against code?
So this gets back to my very beginning point to where these manufacturers are doing the industry a disservice. The guy outright lied. And or at the very least, he did a misconception. The National Code Book is very clear: 15 volts on AC, 30 volts on DC. So everything we do is DC, so we're allowed to go 30 volts. So imagine that is, I'm going to say, safer than AC. National Electrical Code, right, is letting you go double the voltage. So it's safe, and that's a whole other part of this when we get into a power management system as far as our voltage drop and wiring methods and distribution. So how safe is everything? I mean, that's obviously another topic, but that'll be in the podcast. But yeah, so no, he's just
What is that code? Yeah, what is that code? What
so
chapter
it's
and
Article
verse?
4. It's Article 411 in the National Electric Code. It's
There you
very
go. Look
clear,
it up.
very simple. Well,
Awesome.
anybody can probably, I don't even know if you could Google that. I'm sure you could Google National Electrical Code Article 411, right?
Easy enough. Would you
Yeah,
say,
probably should
Nate,
do it right now.
24 volts or the variable system, that Lifetime Lighting Systems makes? This really wasn't meant to be a plug for that, but it is one of our deadly sins, and this is a way to solve it. So I guess it kind of is a plug for that. It helped me learn, much quicker and not have to worry about it. Because 12 volts, you only have so much of a drop before you really have a problem. Would you say, Nate, that the industry at some point, because I tell customers this, the industry is probably going to catch up to Lifetime Lighting Systems and 24 volt within 5 years, and this is kind of the system you want to have. And there's other companies I know, like S4 Lighting, InLight, American Lighting. Like there's a bunch of other companies now that have a 24 volt option. A small
So,
amount overall, but I mean, there's some companies that are moving towards that. Is that a true statement that probably what the future would be because it's just simply better?
so when you get into linear lighting, like some of the companies you just mentioned, they've always done 24 volt lighting. And look at for the past 20 or 30 years, we had the linear strip lighting going down every movie theater that we've all been into. And they had obviously LED diodes every 1 inch or whatever it is. So they had to go 24 volts to minimize voltage up so the LEDs would work. So yeah, smarter manufacturers have introduced 24 volts forever, forever, forever. So will the industry change? Well, you would certainly think it would. The problem with a lot of these manufacturers and distributors, imagine if you're a big distributor that has 600 points of distribution and you got maybe 5 or 6,000 transformers on the shelf that are 12 volts, and you find out that 24 volt is the future now. You got thousands of transformers, tens, maybe hundreds of thousands of light bulbs and fixtures with 12 volt. How do you navigate that? How do you throw shit off the shelf and then return that stuff? So that's a problem with distribution is how do you keep up with the future with old inventory? So that's why it takes so long for everybody to change what they're doing because they don't see any difference between 12 and 24. But I'm going to tell you to where you talk about, and let's just say, Shane, I know you own a Tesla, good for you, right? But a lot of people will buy a Tesla because they want to save resources in the earth. And that's another debate whether electric car does or not, but it's certainly got the perception that you're saving Mother Earth. Well, when you want to go to a client and they're one of those people that want to save Mother Earth, just on the DC to the AC calculation own on volt amps. But if you put efficiency on 24 to 12, we're talking over 200 trillion watts of electricity is wasted every year. 200 trillion. That's a lot of fucking watts that are being wasted, a lot of consumed energy, a lot of money that's being wasted for electricity bills, a tremendous amount, hundreds of millions of feet of 10 wire and 12 wire that's unnecessary. So that's another good thing. And if your client is concerned about energy efficient, that is 12 volts. It's 24 volts. It's a variables. Huh?
I'm going to all my quotes this week. You know, we're not just green this week for St. Patty's Day. We're green year round because we use less
Yeah.
wire.
Yeah.
That's great. That's great.
So, I mean,
Uh,
when you think about it, we are the leading, you know, electrical efficiency power managers out there, bar anybody. And I would just want anybody that's another manufacturer listening to this podcast, come on, babe. Let's go head to head. You'll lose every time.
So,
So,
question: I'm installing a 200 fixture job. How would I test? Right, I'm a new guy. How would I test? Even know if I had voltage drop? At the end of my line. Me, like the quick way, well, I just look straight at the light bulb, and if I see, I probably don't. But I know there's an easier way, and I know the answer to this question. But Matt, what would you do? And do you test that on your larger installs?
Yeah, so for sure, there's voltmeters that you can get that read. You set them to read it, and you can just, you take your readings at the coming out of the power driver. We get 26.8. At the end of that run, you can put them on. We use a pigtail, strip it back, and we can take a real voltage measurement with a load on it to see, and that voltmeter will tell us exactly what it is. I'll say very important that if you don't have a load on, say you run 120 feet and you test the volts and you're like, wow, I have like no voltage drop. Right, I use 12-2 wire. I'm 120 feet away. I have like 26 plus volts. And then you put a bunch of lights on it, and now at the end you have a lot less. You have to remember when you're measuring the voltage with that voltmeter that when you have lights on it, when you have a load on it, it's going to change at the end of the run. Well, everywhere actually, right? But yeah, voltmeter.
If you discovered, Nate, at the end of my line, holy smokes, I'm down to 9 volts. Even on a varivolt system, like I might have a problem. These might be a little dim at the end of the line. Where would I start to problem shoot that?
So a lot of things can happen, Shane. So people don't panic out there, it's always good to do things hot, right? When you're doing your install, do everything hot so you have live electricity going to every light bulb. Because let's say that you had 25 volts, 25 volts, 25 volts, you're doing really good, right? And then you get down to the bottom and you got 9 volts in your situation. Well, how do you go from 25 to 9? Logic might tell you something happened, right? You got a bad connection. You got something that caused maybe a minor short or something that caused massive voltage drop. So if you're doing things hot and in the previous fixtures you had 25 volts, then you can just go back to the previous fixture, disconnect it, right? Make sure everything's good, and then go forward to a process of elimination. But that circumvents a lot of times. For example, seen it so many times to where somebody using a staple gun on a tree or under an eave, and they're putting 20 lights under an eave, and they staple, and then they energize. Okay, so but if you do it hot and you staple, and all of a sudden now there's a short because the bulbs are really dim at 9 volts. Well, that staple went through the wire right there, created a little tiny short, didn't trip the fuse, if you will, right? But dimmed the light bulb down because it had 9 volts. So that's a really good trick to do. Now, other than that, if there was no, no short or nothing happened that you did in the field or your installer did, then it's a process of elimination. If you had 25 lights, I go to number 12, disconnect 13 and on, take a voltage reading, and so on and so forth, and try and do that. But ultimately, you would have to add a wire, or you have to add another home run. Simple as
So
what
start
it is.
halfway, test the voltage drop, and then kind of figure out which
Mhm.
process of elimination. Is
Yeah.
there a chance it could be a bad lamp or a bad fixture or is it always something with the wire?
Well, I mean, what is fixture's advice on light bulbs? How do you have a bad fixture? Is there something that got cut into the wire? Did the socket go bad? Did water get intrusion through moisture migration and shorted the socket out? Can the lamp be shorted out because it's electronics? So the answer is yes, 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 and yes. I've seen the most craziest fucking shit you've ever seen in your life when it comes to problem solving and trying to diagnose a system. And a lot of times you're going to get that one off. Like, I've never seen that before. You know how many times I've said I've never seen that before? Too many times. But usually it's something common, right?
Yeah,
So,
we had a situation, we had a really long run, and we had like 25 volts at one path lights, was the one that I did the whiskey barrel path lights in. And then at the, we did the rest, they're all lit. We took a reading and we dropped down to, I think, like five or six. Like the last light wasn't lighting. And, troubleshooting wise, methodically, we found out that, two lights back, the wire looked good. The lamp was still lit, but the wire where we had put in, we had like, slit the wire a little bit. So it was kind of opened up. And that was what was causing all that voltage drop. So, just to say, like, there shouldn't have been voltage drop. And then there was just that extreme voltage drop. When that happens, it's most likely what Nate was just saying, something that just happened. So when we do it live, we knew right away, hey, it's in these back 2 or 3 fixtures. It was something we just did, just screwed everything up. And that is super beneficial and saves a lot of money in the field and labor.
well, so Shane, you just said, could it be an LED bulb? Well, yeah, I mean, maybe one, I don't know what the number is. Let's pretend that there's one LED bulb that's bad out of every 1,000. Okay, that's 1/10 of 1%. It's probably a reasonable number. Well, I mean, if I'm doing it hot, I'm going to catch that bad light bulb that might create a short, right? If I'm not doing it hot, what a nightmare. So it's easy. There's no reason not to do it hot. None. You don't get shocked. There's no you're not going to get electrocuted. There's no reason not to do it hot. Go back to
Well,
halogen days. There was never a bad light bulb. The light bulb was either working or not working.
like you install 30 fixtures on a line and don't do it hot, and then make it hot right at the end of the day before you leave and realize you have a short, you won't make that mistake again. Spending a couple hours at the end of a long day trying to figure out that needle in a haystack is a in the butt. That is a true nightmare. So we made
That is a true nightmare.
and we're always hot. Now that we've made that mistake, you only have to do that once. So real life question here. For Nate or Matt, whoever, I've got a job coming up, right? It's going to be a super long trench line, 500 feet to the front of his gate to light up some trees. Maybe we'll put 10 lights or something in the trees there. Now I know, like with a 24 volt varivolt system, well, I probably don't really have an issue, but would I if it was 12? And I guess how would I math that?
So here's a little trick, right? If you can, without having to go into the voltage calculations and all that stuff, we only use a 4-watt bulb on DC, so it's true 4. So you're going to get about a 1 volt drop per every 100 feet on 12.2 for every 7 to 8 fixtures, right? So you can pick a number 8, you can pick a number 7, right? So for every 8 fixtures, you're going to get a 1 volt drop. So if you had 8 fixtures 500 feet away, that'd be a 5 volt drop. Okay. So on a 12 volt system, that would be a big problem because you'd be at 7 volts now. Even if you went to a 15 volt tap, you're at 10 volts. So that's where it would be impossible on a normal 12 volt system. If it's a normal 24 volt system, 24 from 5 would be obviously 19, can't be done. Varivolts, you would have 19, nothing matters. And that's only at 8 fixtures, 500 feet. So if you had
on a
Go ahead.
12 volt system, well, the answer would be I would need 2 500-foot home runs, which would cost me another $400-500 in wire. Not to mention,
or go up 10 to 8 to. I mean,
right, which is still.
And if you guys want to make notes and have your cheat sheet, so what is the difference between 10.2 besides money? What's the difference between 10.2 and 12.2 and 14.2? So 10.2
4 coppers versus 90 coppers.
Well, I mean,
That's a stupid guess.
yeah. Let's just admit, I don't even know what changes. We'll just pretend, we'll just ignore him.
Copper
Um,
strand.
So you want to make a little cheat sheet. So 10-2, it's all 40% more. So 10-2 is 40% more, bigger carrying capacity than 12-2. 12-2 is 40% more carrying capacity than 14-2. Okay. So if you had a 5-volt drop on 12-2 and you were going to up it to 10, well, 40% of 5 would be technically 2. So you'd have a 3-volt drop, right? So you're still right there pushing the envelope on 10-2. So it doesn't really help. And even if you go 12-2, like you said, you got 2 12-2 runs, you're maxing the system out. You can't even, you don't have anything for future considerations, right? And if you're going AC, that was on DC. So let's go back to what everybody, unless you're really buying my product, we got to talk about the rule is now not 8, the rule is 4, right? Because you got volt amps. So really now the rule's 4 or 5. So now you got 4 or 5, right? Fixtures for a 1
Whoa,
volt.
whoa. What do you mean? I know what volt amp is, but you're talking like everyone does. And I know we talk about VA, but when we say this, people say we sound like liars that we don't have volt amps because they've never heard of such a thing. A landscape lighting system that doesn't have volt amps. How's that possible? Give us a little rundown of how that's even possible.
Well, Matt, just to clarify, did you say that most of the people listening don't know what a volt amp is? And we need to explain
No,
that?
they know what a volt, well, probably not generally. They just know there's volt amps. I
Okay.
know from talking to so many of them, basically they just get told, hey, when you buy a 4-watt bulb, it's actually like 6 or 7.
Okay.
And why? It doesn't make any sense.
So it's one of those things to where, does anybody even know how electricity works? It just shocks the shit out of you if you touch it. How does it really work? Pretty sure no one knows. It's magic. So back, just so you know this, because I was in my previous life owning Unique Lighting, I manufactured multi-tap AC magnetic transformers in the United States. And we would do factory tours, and I would tell everybody that the magnetic transformers worked under a principle called FM. And most people would guess, what is that? Well, what would FM mean to you, Shane and Matt? Right? That's what a transformer works under, the principle of FM. What's FM?
Fucking monkeys.
Fucking magic. No one even knows how they fucking work. It's
Close.
crazy,
Fuck.
right? So a lot of people would guess, frequency modulation and all this crazy stuff. So volt amps is just a mysterious thing that when you have a device that is a DC device, LEDs, TVs, computers, everything, and you happen to feed it with AC, it goes through this magical conversion and creates more energy, right? Wasted watts. So imagine if you can think of an analogy, which I don't know, maybe a 4-cylinder vehicle. So you got a 4-cylinder vehicle that maybe runs okay, right? But now once you put a lot of weight in it, like a bunch of bricks or concrete bags from Home Depot, you got to go up a hill. That 4-cylinder barely, it's just going so slow. It's struggling. LEDs are the same way. They're a 2-inch little tiny round thing. They have to have some type of heat dissipation to remove all the heat, because 2 things will kill an LED light bulb: heat and moisture migration. So imagine now it pulls 7. The amount of energy it's pulling now is 50, 60, 70% more. So now it's working harder. It's getting hotter. It's working hotter. It's called thermal runaway. The harder it fucking works, the hotter it gets. The hotter it gets, right? The harder it has to work. The harder it has to work, the hotter it gets. So it's crazy, the inefficiency of the LED. So, but it just happens. It's a phenomenal. It's crazy. It's too technical. We don't care. It just happens. So with the volt amps, your rule now would be 4 to 5 fixtures is 1 volt drop every 100 feet, right? And that's on 12 too, right? So
I'll
it's
say
massive.
a fun thing you can do is at your own shop or wherever, is if you have one of Lifetime Lighting's power supplies versus any other power supply you can buy, a 12-volt AC magnetic, you can literally hook up the same line. I've done this. I do it in my showroom. You hook up the same line, you put an amp probe around it. You can see that the same fixtures are going to pull about 50% more energy than on the same thing going DC. something you can do live in person. You can see it for yourself. Same exact lights, same exact run. Hook it up to an AC, do an amp probe, then hook it up to DC, do an amp probe that reads DC. And you will see that we're not liars. You'll say, holy mackerel, this is amazing.
Holy
Shane. Golly gee, guys.
Golly gee, geek.
Well, I think I went way longer on that topic that I even thought we would go on, but I don't know. I thought that was some pretty great info. Anything else that I didn't cover on this 7 deadly sin, the 5th deadly sin here, that would be good for the audience?
Well, I mean, obviously, on another podcast, we can really go dive into AC versus DC, 24 volts, maybe into 12 a little bit more detail if we wanted to. I think on an overall, it's good what we did. The other thing is just a wiring method, right? So, and I don't know how much time we want to get into that. If that would be another subject matter at all, it probably should be. But we did not get into wiring methods.
Okay. And when you say wiring methods, you mean like you could daisy chain, or you could run all the lights to a hub and have one central connection. Is that what you mean when you say wiring methods?
Yeah. It's the voltage distribution. How are you going to go from the power supply to your fixtures? And right, the typical method, probably 99% of the people do, is a daisy chain. Run a 12-2, just come out and linearly hook up to the 12-2, right? And then the hub method of wiring, they bring all same leads into a central point of connection, right? And then there's obviously the T method, and there's a new method we came up with, fixture to fixture. It's kind of a different method. Yeah, I mean, those things are, maybe we come back in different podcasts. We have a link to some charts or whatever. But it's important to know the reason you pick the wiring method, right? And there are specific reasons why you pick one method over another.
Mm-hmm. Yeah, I mean, we can go probably 20 minutes down a rabbit hole there. When you're in a hub box, label your wires, actually use a hub box, have it in your as-built or your diagram, however you do it. Use copper crimps when you're making a connection, put everything in grease tubes. Certain rules that we, kind of make sure they're the same on every job. And this is kind of, learning from Nate. We also, make it to where 12-2, goes to the home box. So if we see 12-2, well, we know that goes home. Then we use 14 gauge wire, as our secondary wire. So we know that would go to a secondary hub box. And the fixtures have 18 gauge. So if we do the same thing on every job, it's really kind of easy to know. And there's just really less documentation that's needed because we do the same thing, every single job.
I'll say too, like this probably get pretty confusing if you're just listening to audio or watching the video, right? This is something where one of our live trainings definitely comes in handy. We've got one next week or this week actually is happening. We've got a couple in April. We got one in San Marcos or San Diego area. We got one in Dallas, and we got one in Albany, all happening in April. So a lot of this stuff, it's great to learn, kind of let it soak in. But then when you come to a training, ask questions, see it happen live, see what happens when you put an amp probe on different things. It can really hit differently. So I just want to encourage guys, like, if this is like seeming over your head or too technical, it's not. That's what I love about our lifetime lighting systems is it's simple. I'm a lighting guy. I don't want to be a math guy. And so how we teach it takes all this complicated, shit and this jargon and just allows you to focus on the design and making more money rather than diving in deep and having these calculators you carry around in the field. So I just want to encourage guys that we do have live training. We got a bunch of them in April from east to the west coast and right in the center. So
when is your training there in New York, Matt?
Training in New York's April 10th and 11th.
Gotcha. How much does that cost?
It's $199 to reserve your spot, and then you come and as long as you come, there's some stuff you can take a credit towards demo kits, lots of cool things there. You can check out lightingtradeschool.com for that information though.
Got it. So it's basically free, $199 to reserve your spot, but you get a credit to use that towards a tool to get you started.
Yeah, I'd say it's actually I'm paying you to come because you can get credit towards your demo kit of more than you're actually buying. So mind blown. I'm going to pay you to come get trained.
All right. And same thing, there's going to be a training in Texas April 24th and 25th. Or some of you guys that might be a little closer to Texas versus New York. And go to lightingtradeschool.com. You can register. You can check out everything there is. Also, check us out on Facebook. We've got a Facebook group, the Illuminati Lounge. Lots of good info. We're posting in there daily. And did I leave anything out there? Our sponsor, for the
sponsor, but also when's Nate, when is your training in April?
So I got a training next week. And then I've got a training April 14th, and they're 5-day trainings, very advanced, 12 hours a day, 15 hours a day. So you work really hard. But yeah, April 14th.
All right.
The advanced training there with Nate is vastly different, far more hands-on, and far more knowledgeable than the 2-day training events in New York and Texas.
For sure.
All right.
Who is our sponsor? This we forgot to talk about that at the beginning.
I didn't even say it. So sponsor Lifetime Lighting Systems. Clearly, we've kind of been talking about them only because it makes sense as a lighting person. Like, why would you not use a 24-volt varivolt system if it basically costs the same, saves you wire, runs better on a system, takes the math out of it? It's just really kind of a no-brainer. So Lifetime Lighting Systems, there's the plug for that.
And
Plug
it's
for
safer.
that.
And it's safer.
And it's safer.
Than AC.
Yeah. Hell yeah. All right.
Good deal,
All right.
guys.
We should have an outro with the AC/DC band, right? Like one of their most famous songs. I don't know what it is, but we ought to find that.
Back in
Oh,
black,
that could
Highway
be
to
cool.
Hell.
All right.
All right.
Guys, see y'all next week.
Take it easy.
All right. Take it easy.